Hi, everyone. It's a pleasure to welcome you all to the Capstone Projects once again. Capstone Project presentations of the Hamuye Internship Spring 24 cohort. My name is Mercy, and my job at Amuye is to make sure you have a smooth experience. I will be joining you from Ibadan. I'm joining you from Ibadan, Nigeria, and will be your host for today's event. Welcome, everyone. At the core of Amoye's vision is a mission to nurture a community of problem solvers through our internship style training in data-centered careers. We take immense pride in the success of this mission, and it's a source of great joy to witness the remarkable accomplishment of our interns in the Spring 24 cohort. These talented individuals have harnessed the power of generative AI and machine learning, working with diverse data sets spanning climate change, health, infrastructure, and more. Our interns were opportune to collaborate with cross-functional teams on what we have tagged the capstone projects. They have explored their respective data sets, unearthed valuable insights, constructed and deployed cutting-edge models. Now they are busting at the seams, eagerly prepared to share their discoveries with you. In an equally special manner, we would like to extend a warm welcome to members of various data science communities in attendance, esteemed Amoye Fellows, dedicated Amoye Internship alumni, and of course, our exceptional interns who have reached this impressive milestone. Your unwavering commitment and exemplary performance thus far deserves a hearty congratulations. And now, welcome to our esteemed judges. The first judge on the list is Dr. Biodun Awujobi. They're not here yet, but we are hoping they will join us soon. Dr. Abiodun Awojobi is a PhD holder and has been in the informative technology industry for over 15 years. He backed his PhD from the University of North Texas in information science and cybersecurity. He received his MBA and Master of Science in cybersecurity from the University of Dallas and also bagged a degree. He bagged a Bachelor of Science degree in Electronic and Computer Engineering from the Lagos State University, Nigeria. Biola has worked in multiple IT software companies over the years, and he currently leads a team of customer engineers focused on infrastructure, application, modernization, data analytics, AI, ML, and security for the Google Cloud platform. You're welcome, Dr. Abiodun Awujobi. All right. So
Thank you
next
very
on,
much. Thank you for having me.
yeah, thank you so much. Then we have Peter Iroja. He is the CIO of Pyro Labs, a company which helps clients to migrate fully to cloud-native business analytics solutions. He loves automation, orienteering, and learning about new technologies such as AI. You're welcome, Mr. Peter. And then finally, we have Charles Adetiloye. Mr. Charles has over 15 years worth of experience consulting and implementing large-scale data processing, AI ML software platforms across different industry verticals. He has previously worked with Lightbend, Twitter, but to name a few. He is the CEO and co-founder of one of the most successful providers of consulting services and builders of large-scale distributed reactive back-end systems, Maven Code. Charles has over a decade's worth of experience in machine learning operations. Welcome, judges. We are so glad to have you with us. Thank you so much. Just before the presentation begins, please take note of the following. Each team will only have 7 minutes for their presentation. We have said this before that anybody in this presenting who shoots over their time, they are going to get it. The whole group is going to get penalized. So please don't do that. Don't get your team penalized. We told you to rehearse, so please we know that by now you would have rehearsed everything you need to say, and under 7 minutes you'll be able to say that. Thank you very much. At the end of every presentation, we would hand over to our judges for their questions and comments. If a team is not available for its presentation at its allocated time, and it's alphabetically done, so Bert is going first, and then we have Bigan, then we have Dal E, then in that order. You know what alphabetical order means. Okay, feel free to use the comment section for your comments and contributions. And finally, dear presenters, try your best to be concise and straight to the point. Remember, you have just 7 minutes. Now, I will call on the first team to present. We hope you're ready, Bart. Babatunde Akonfe and Chukwuebuka Obi. I hope I'm pronouncing the names well. Chukwuebuka Obi and Babatunde Akonfe. Where are you guys? Are you ready to go?
Hi, good afternoon. So our co-presenters are Fatima Adwan and Prosperity Ogama. So we'll share our screen now.
Okay.
Okay, hi everyone. My name is Fatima Adwan, and here with me is my co-presenter, Prosperity Ogama. Our topic for this project is AI-powered remittance chatbot, where you ask the chatbot questions on remittance and it gives you answers. Next. Next. Prosperity, next.
Sorry, I'm trying to move it, but it's not.
Okay, so next will be our team members' names. And okay. Okay, so remittance is generally just the money sent from abroad by migrants who migrated abroad to their family members back home. Remittance happens to be one of the major sources of income in major countries, especially developing countries. Nigeria alone happens to accrue about 19.5 billion US dollar in remittance, making it a major contributor to Nigeria's GDP. Here we can see some other parts of the world that some countries who accrue remittance as part of their major income source. For instance, now all of these countries that has been seen in this chart, none of them is below 17.1. None of them is below 17 billion US dollar. Next. Okay, so as we all know, that remittance is a major player in the development of a country's GDP. And so the method of obtaining or accessing remittance information happens to be static and kind of like lack in real-time interaction. And so the aim and objective of this our project is to develop a chatbot that will enable individuals to ask questions on remittance and answer questions in real time. Next. Next is our methodology. In our methodology, we started by collecting data source from various sources in form of PDFs, CSVs, XLS, and then we pre-processed the data set and then converted it in a form that is suitable to be used for our models. And then the next step we went is make research on large language models, where we accrue a lot of research and made a lot of researches on LLMs and select models that are suitable for our work. And then we selected the models and fine-tune our models on the data set that we accrued, and then deployed the data set to Streamlits locally, and then later deployed it globally for anyone to use. Next. Prosperity.
Okay, so for a deeper explanation of our methodology, we use the method called retrieval augmented generation, which basically allows us to fine-tune LLMs on our own data. So how it works is that we know that machines don't understand text data, but the data we obtained was in form of PDFs and CSVs. So the data is converted into embeddings, which is a numerical format, and then stored in a vector database. So when the user asks questions, the questions are also converted to embeddings, which are then compared with the embeddings of the data available. And then the closest, there's something called closeness similarity, where it checks the closeness between the embeddings of the query and the context, which is the data that we gave it, and then it gives you the most related content as your response. So for our results, we've developed two applications. The first one receives like you could upload your own PDF data and obtain results from the model. But since we're given a particular topic to focus on, which is remittance, we decided to build another app which we trained on remittance data from various sources, and then all the user has to do is to ask questions and get answers. So these two diagrams show the different methods that we use. The first one is where you upload your own PDF on the app and get responses, and the second one is where we trained with the PDF in the backend, and you just ask and get answers.
Okay, so during the process of making this project, we encountered a lot of challenges because we use different approaches, use different large language models. We tried the best we could using free resources. We started with approach one, which is the Olama models. The Olama models happens to be free, but they come with a lot of challenges. For example, they work slow with CPUs. They are mostly best with laptops that are using GPUs. And at the same time, again, when you're using them on CPU laptops, they tend to be very slow. And then you call the model the first time. After using it, then for a second time you want to use it again, you call the model, which makes it a bit difficult and slow and time costly. The second approach we tried was models from Hugging Faces. We tried the GPT-2 and the GPT medium. Although these models happen to be free as well, but they also come with their own challenges, which include poor results obtained, in the sense that when you ask the models happen to be a bit unintelligent. I won't say completely unintelligent, because from the training we did and the observation we did after some time, we observed that about 50 to 60% of the answers the models give are kind of incorrect. And so we had to choose another approach, which is the GPT models. And for the GPT models, we went for the 3.5 tuber. This model only came with the challenge of having to pay for an API, but this model is fast, reliable, in the sense that more than 90% of the time, whenever we ask questions, the questions are always accurate, and they give the best answers from the files that we upload, or from the files that we fed it in the beginning. So in our conclusion and recommendation, I would say that retrieval augmented generation improves the quality of LLMs by using an external data source to make inference and build richer prompts. And then for further improvements, we recommend that building a better user interface, exploring more models like the short-term learning, and then supervised fine-tuning. Next, we're going to show a display of our app display of our app globally. So this is the app. You can ask it as much question as you can. Be frequently asked questions about remittance, and it gives answers to your questions in real time. So the app is loading. Okay, so this is a typical question that you can ask and it will answer you. You can ask other questions that are relevant to you, and at the same time, you can ask other questions like this one that we are typing. Okay, so
we also have chat
okay.
history feature that kind of stores old conversations, and also it has contextual memory, in the sense that you can make reference to a question you asked before and it will still understand what you're saying. So thank you very much.
So we're sharing the link. You can access the link globally as well. Thank you. Thank you so much as well.
All right. Thank you so much, Tim Berth. That was a good one. So, do we have any questions or comments from Biodun?
It's a good project. I I I don't have any critique. I'll just love to know what are your next steps from where you are right now. I have a little bit of a cold. That's why my voice is coming up in the room. But yeah, I would love to know what are some of the next steps that you're thinking about from where you are right now.
Sorry again, the
Okay.
question, the network. Okay, go ahead.
We would like to um train it on more data, because now we had to limit the amount of data we use, because the more the data we use, the slower the app takes, the longer the time the app takes to load. So if we have access to more resources, we could use more data and get better results. Also, we could improve the UI, of course. Putting too many elements on the UI also would have affected the speed of the app loading. So with more computational resources also, we would improve the UI to be more visually appealing and interactive and user friendly.
Yeah, just a thought for you as well. I mean, look at the remittance space. There's a lot of players in there that have disparate business models. As a next step, I challenge you all to just think about like the top five remittance companies that are even local to Nigeria, or you could take it from even an Africa perspective and say, with what you have right now, what additional components or what additional capabilities or features would make these companies want to partner with you, or would make what these companies have be 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 complementary with what you have created, such that if they add a feature that you built out or a component that's currently in your system, how could it work? So think about it from that perspective. So this is sort of end up as a lab experiment. This can end up to be an actual product. Because I think there are, with some work, there are opportunities for you to take it to the next level.
Okay,
Thank you very much, Bo.
thank you
Thank you.
so much for this. We keep that in mind. Thank you so much for this observation and the feedback, sir.
All right,
Pleasure.
that's fine. Thank you so much. Would that be all from Biodun?
Yes, that would be all for me for now.
Okay. All right. Peter, any thoughts on the just concluded presentation?
Oh yes, thank you, guys, for presenting. As always, I'll just like to ask. You mentioned a few things, and one of them was the limitations that the technology provided you, where you said the model was not scaling because you did not have enough compute. How did you come about this conclusion? I'm just keen to understand how, and did you try to integrate into any um, cloud providers there, or do you think integrating into any cloud computing will help?
Yes, integrating with cloud will help, but we would have to spend money to do that. And um, I don't think people are not exactly willing to spend that much money, because we still spent money to get GPT 3.5 API, but paying for cloud is like a whole different ball game. But how we know that compute is the issue is that um I think one of my colleagues downloaded one of these models and it took like 40 gigabytes of her local storage. So I mean that's a lot. And also she had to reload the model every single time she needed to run the app, and it took hours. So definitely compute is the issue. And yeah, cloud storage would definitely help.
Okay, and just so what will be the next step? I know my colleague already asked you that question, but do you? I also want to encourage you, I guess, as a next step to look at how you can approach other providers and find out if there are ways you can add value. Perhaps maybe you can leverage some of their cloud computing platforms and stuff, because I think it's a very good idea. you have here. It's just obviously you have limitations, but these are very soft limits that, to be honest, you can overcome. But yeah, good work.
Okay, thank you so
Thank you.
much.
Right. Thank you very much, Mr. Peter, and thank you, Bart. So on to begin now. We have Bharat
One last
Kumar.
question. I think you skipped me.
Oh,
Hello.
okay.
That's it.
Oh, all right. Sorry, Charles. You
It's
have
all right.
something to say.
Yeah.
All
So
right.
quick one. Can you talk a little bit about how you created all the embeddings to store this data in the vector DB?
We used LangChain library, and then I used OpenAI embeddings to convert the context as the data we fed in into embeddings. And then we used FICE vector database as the Facebook AI similarity search, which then does the cosine similarity and compares your prompt to the context before giving you results. So
Okay. And what kind of vector DB did you use?
FAISS,
What?
FAISS, Facebook AI similarity search.
Oh, okay.
Because we
Okay. Then I don't think you mentioned it in the slide. That's why I'm trying to understand this call things. Do you
Okay.
have a
Sorry,
place?
we tried not to go into too much detail in order not to waste time.
Okay, all right.
Okay.
That's okay. Then the PDF and CSV files. I mean, I just want to understand how you created the embeddings for that because they're two different kinds of files. The PDF will become documents. The CSV are just numerical values. So how were you able to like combine that and score them properly? Basically, I mean, I just want to understand how you made sense of what's in the CSV compared to the
Okay,
PDF.
so the
okay.
PDF sends them directly, but CSV does not necessarily have to contain numerical data. We found out from some tutorials that you could even copy whole websites and upload them into CSV files as text, and they would still work well with the models. So yes, the CSVs did not just contain numerical data; you can have text in them as well.
Okay. And in terms of how you build everything,
Okay,
including
so in forwardance to what my colleague said, when we collected different data set, it's some of them came in the form of PDFs and some of them came in the form of CSV. So after like much cleaning and pre-processing, some of those PDFs they also have tables that contain informations as regards to the remittance and all of that. And then the ones that already came in the PDFs, as usual, you do the cleaning, you remove the unnecessary ones that are not needed and all of that. After making all of that, after doing all of that process, then we later came back like, okay, we have to make a point. We first of all tested it with only CSV. We tested the models with only CSV files, and then we discovered that if you feed them with only CSV files, it's kind of like take longer time, and at the same time, sometimes it checks the columns, and then it might get an information that maybe this column and this column are having that kind of similar something, and then the answers are not correct. When we go back and check, we check that the answers are not correct. So what we decided to do is that we went back. Some of those PDFs, they have like key points and explanation of some of those columns and all of that. When I said, okay, this will make sense if we convert the CSVs back to PDF and then feed them to the middle. So all we did was that the CSVs were converted back to PDFs, and then we added some of those key points that explained the KPIs and all of that, and then fed it to the model and then asked questions. Then we discovered that the answers the model was giving was like more than 90% accurate.
Yeah, well, but don't you think converting back to PDF made that compute process a lot more expensive because normally it's easier to parse a CSV file than PDF. I understand the fact that the parser you're using only understands PDF. I mean, that's what was why I really wanted to understand how you guys were doing the embeddings and getting the data in the vector DB. But we can take it offline. I'm really interested in what you guys are doing. This is great. One last question before I let you go. What kind of framework were you using for the entire setup? Is it LangChain? Is it Olammer?
Yes, we used LangChain and called the GPT model from the LangChain library.
Gotcha. Okay, so you got your token on OpenAI and you're calling it and passing it. Okay.
Yes, yes.
Okay. So because if you go back to the slide, I'm trying to correlate. Well, I think I saw Olama in one place, then
Yes,
Okay.
we
I
Yes.
saw
explained.
OpenAI in one place, and OpenAI is a managed model. Olama is a model that you download. Which of the approach did you guys take?
Okay, so what happens in the slide? Prosperity, can you share the slide back again? Okay, so what happened in this slide under our challenges was that we did like we had like three approaches, which the first one was we tried the free sources. You know, Olama is free, right? Like their models and the platform and everything is free. So we
Mhm.
tried the first approach, which is Olama.
Mhm.
Then what happens was that both of us, not like both of us, like most of us in the team, we only have systems that are based on CPU. We don't have systems that are based on GPU. Olama models are like some of them, not all. There are some of them that are very light, but the ones we tested are heavy. That's number one. And number two, Olama. Another problem with Olama is that it had compatibility with Windows. Or like if you're using a Linux or OS or a MacBook, it would have been better. But all of us in that group were using Windows, and
Mhm.
that's another challenge that we had. But we found a way by using like virtual box within our Windows, right? I mean our Windows operating system. But then the problem that came in is that after calling all these models you are seeing here, the models are kind of heavy. These models, the Gamma 2, Mistral, Llama 3, and there's another model again that is not here. After calling the 5 models to use them, it took about 50 gigabytes of space of my system.
Mhm.
So that alone is kind of like heavy. And then after computing the whole project and then calling the models and then fine-tuning them, like each of them was fine-tuned in different file in the same folder. After fine-tuning them, at the end of the day, okay, so we left it and we thought we were done and this is fine. And then we came back the next day. We had to call the models again, which took about like a whole 24 hours for the models to download on a Windows operating system working on CPU. So that's a
Yeah.
whole lot of
Yeah,
challenge,
yeah.
and
I get it. It's quite a challenge trying to like run like your model, so it's better to use something that is hosted out there like Gemini or OpenAI. So, but my question was like, they're small token size models. Did you consider that, or was it going to be relevant in terms of the output it's producing? It's not going to be accurate enough.
it's kind of like relevant in terms of the output. The smaller model, like the Fit 3 that we used,
Yeah.
the response we're getting, and then we have to check for the accuracy and all of that. Like it's not that intelligent. It doesn't give answers like the way we want them, and so we had to like opt for the bigger ones and the heavier ones, like this ones in the slide. But these ones came with a lot of
Yeah.
cost, which we don't really have.
Okay. Great job. Do you have the source code? If you do, I don't think I saw it in the slide anywhere. Just if you can post the report to the group chat, that would be very helpful.
Okay, that's
Okay,
fine. I will do
link
some
to the
little
app
cleaning and uploading and then send
is
it.
All right. Thank you.
link to the app is in the chat, so you can try the app out.
Yeah, I want to see the implementation as well.
Okay.
Sir?
Yeah, I mean, I saw the link to the app, but I was really interested in the implementation. Now you guys did what you did.
Okay. So we deployed it globally. Anybody can ask questions as long as the APIs are still, we don't run out of the
Yeah,
fund we funded it.
exactly. Be careful what you ask for because if the global people descend on it, it's gonna crash it.
I think Prosperity should go and remove it because the APIs we just finished. Thank you
Exactly.
so much,
Because
sir.
you're gonna lose all the tokens. All right, great job. Thank you guys.
Thank you so much.
All right. Thank you so much, Tim Bert. Thank you, Mr. Charles. On to Bigan. Are you guys ready? Bharat Kumar Jawar and Adini Yolaolu Peter.
Hi. Yes, we are ready. Let me share my screen.
Hello, I thought you guys said okay.
Is my
You were
screen
ready.
visible?
Yeah, your slides are visible.
Okay. Hello, everyone. Good afternoon to all the judges and Hamoy members. Myself, Bharat Kumar Jhawar, along with Adeni Olaulu. We are representing Team Began and we are here to present our work on the issues of electricity faced by sub-Saharan Africa. This over here is the content of our slides. Our problem statement tells us to develop a generative AI model capable of accurately forecasting electrification demand, supply, and the resulting gap to guide effective and sustainable energy access intervention in sub-Saharan African countries. So, as to begin with, our first objective is to give a comparative analysis between sub-Saharan Africa countries and also between the region outside of the sub-Saharan Africa countries. Along with that, we are to provide data-driven insights for supply and demand and predict the gap between them in the sub-Saharan country, creating a robust model and ensuring that the model adapt to the new data input, continuously refining our predictions and strategies over time. As usual for every machine learning project, this was our process flow during the 1 month of time. Coming to data collection, Hammer provided us with 3 datasets, out of which we got our valuable information from the World Bank data, but we needed some more. So we went on to search for other datasets, such as tracking SDG 7, our world in data, Amber, UN data, and then we provided, and then we started doing the data cleaning and pre-processing. Data types were corrected, unit of measurements were standardized, some categorical variables were encoded to numerical variables, and columns name were also standardized. The missing values were filled with various lots of models such as forward fill and backward fill, but the best model that imputed with the missing values were profit model. We also dropped few columns, few countries which has lots of missing values, and finally we got ourselves with a data set of 48 sub-Saharan Africa countries. We did various EDA and various comparative analysis, but today I want to show you the main thing that how we come up with our target variable, that is the gap. Population variable is clear, the supply variable, the actual amount of electricity delivered within a country, including generated and imported electricity. Access, the percentage of total population with access to electricity, and then the supply rate, supply by access, the simple equation, and then the target demand, the total amount of population that is 100% multiplied by task supply rate. And then we find ourselves our target variable, which is the simple minus of target demand and supply. The variables are defined here. And now I would like to give this to Olaulu to come and complete the rest of the PPT. Thank you.
Yeah, thank you so much, Bara. So welcome everyone again. So we proceeded to modeling, and we talked about 3 models. And the first is using the traditional reverse relational machine learning model in gradient boosting, and we also used sequential model with LSTM. Previous slide, previous slide, previous slide, previous slide, previous. Yeah, good. So while using this, we had an ratio of 2.9. Next. So we proceeded to sequential model using our dense as our layer, and we have a combined RMSE of 5.1. But looking at this trend loss and test loss, we realize that it's a little bit large. Next, 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 next. So we proceeded to using our same sequential model with LSTM layer, where we had 4.4 as our combined RMSE, and looking at this string loss as well, they are still a little bit big. So we talked about what we could do to make this model performed better, because this actually says predicted value is a little bit is a little bit far apart from actual value. Next. So keep our model backtesting. So model backtesting simply says going through our processes to look at what we could do to make it better. So we had we came out with these 3 thought processes: feature scaling, outline analysis, and feature selection. So these above 2 processes are already been dealt with. And so we focused on feature selection, where we're about to do what we call feature relevancy using this graph to realize that there are still other features that will have made our project, that will have made that will have made our model perform better. Next. So adding these features and doing some other processes, we realized that our RMSC became lower and our model performed far better than before. Looking at this RMSC, we have 1.7 for using gradient boosting. Next. Then using sequential model with LSTM, you will see from the graph, and you will see the RMSC we have 1.4. And looking at the train loss and test loss, they are very close, which means the model now should predict a value that is closer to the actual. So from this, we went on to what? To deployment. Next. So in our deployment stage, so we made use of Trivers, or we made use of Render as our third-party server, and we wrote our API using Flask, Python, and we designed a front-end app, so where it will be used globally. So next. So these are app. So after creating this app, and after it has been deployed, so you pick your values. You pick your values for any country, say Zimbabwe or Nigeria or whatever. You put in your values in there. You put in the year and you click on predict. So this, after putting these values, so this from here, it's been routed back to the API where every calculations and every process is being done. And once you click predict, oh yeah, good. So this is the app. So once you click predict, then it returns a value. So with this solution, we realize that it will make power agencies more aware of what it's supposed to do. And can you see? So I think this is just some random values. So guys, let's put the correct value. The gap should not as big as this. So we can test this globally. It's been deployed globally. You can take values from World Bank or database or from anywhere, put in your values and click produce, and I'm going to do that. Next to the slide, perhaps to the slide. So conclusion. Okay, thank you. Conclusion. So we realize that the evaluation in these science projects are very essential. After evaluation, our model predicts and perform far way better. Next, and these are this is our GitHub repo and other references. Yeah, thank you. Thank you, everyone.
All right, that was just on time, Team Began. Well done for that. Peter, do we have anything to say to them?
Hi guys, well done. That's a very good presentation. I like this because it's similar to something that I have been part of in the past, where we were trying to predict electricity consumption for a substation. And one of the biggest challenge we had was getting good historical data to sort of, create a model. So one question I had for you is, given your model, what are the different components of the model that, because I don't think I saw it in the slides, maybe you can share, but how did you derive the models? What are the key variables that went into your model? Because I don't think I saw things like weather and all those things, or perhaps you hadn't talked about it in the presentation.
All right, so let me pick it from the first question here. So we actually had a similar challenge to what you said. So, and we've been mandated to use a generative model. So from the slide, you will realize that we actually need to make research on a whole lot of databases to derive, because the data being provided for us by AME were not just enough. Just as you have said, key features. So a lot of features are being used. But I mean, Barat has already shared some. So we had to look for like electricity assets, which country, electricity assets rural, electricity assets urban. So we look at energy generation from different sources as well. We pick data from them. These are being picked from different sources. I mean, we explore like I think 7 or 8 sources, if I'm right. So we data cleaning it actually took us a whole lot to get all this stuff together so that our model will be robust. So we took all this and made use of all these features. We made use of other demographic data too, like even their GDP, use of GDP, population without electricity, a whole lot, and going down to modeling. So we actually tested and made use of a machine learning model first, which that's gradient boosting, or which is an ensemble. So applying that, we realized that it worked well. So, but we proceeded using a generative AI model. So few challenges we had were, so personally, so we came through one of this model called Super 3CC. So I think that was the model that was being like a custom model, basically deployed for anything that has to do with energy or rainfall, anything that has to do with weather generation. But it's all challenge because it has to be or it has to be basically like it's consuming a whole lot of memory from the cloud. So we sort of alternative. Then we came out using Keras from TensorFlow, and which is also generative AI model, and it worked very well with our resources. So that was why we explored Keras with dense layer, using our 64 as our first layer, and Keras with LSTM, and those are the results that you were able to see. I don't know if I'm able to answer your question.
Yes, you did. And maybe just a follow-up question there is, I know you just mentioned that your model did very well, but can you just share some of the results or the scores that you used to classify the successful criteria for your model?
All right, Bharat, can you share the slide again? Can you go to slide? Can you go to slide? Bharat, can you share the slide again?
Yes, sure.
Oh, okay, good. So yeah, good. Okay, so yeah, before backtesting, without training. Yeah. So if you look at this, this gradient boosting, so RMSE, I mean, root square error, 2.9, it's not bad when you look at this result. This basically means a plus or minus 2.9 for every values in terms of square root. So, but then we felt like this we actually fine tune this to perform better, because looking at training loss, some of the results are not, because not to make our wait here, it's okay. No, go back. Not to make our slide too much cumbersome. So we prepared some of the results for like countries, for like top 10, top 20 countries, and we compare to the regional results. So when we look at that, the results were close, they're actually closer, but when we presented to generative AI model using Keras, looking at this RMS is not that bad as well. You can see from the graph, but it couldn't pick a lot of points. And looking at this train loss, no, go back. Yeah, okay, it's fine. Okay. Look at this train loss. This is 32, 36. It's a little bit big. This is saying our predicted value is 32 points. I mean, it's 30 point difference from our actual values. I mean, this is not, I mean, performing the way we actually want it to be. So we proceeded. Next. Looking at LSTM, actually LSTM long short time memory performed better, but then 2014 is still big. If you look at it, 2014. So next. So after model back testing, you could see the results. You could see the same gradient boosting, we have a RMS of 1.7. Next, and now I'm going to focus now. Look at this train loss and test loss. We have 2 and 2. So which means they are very close, which means the model is not overfitting, and it has learned well from the training data set, and it's also predicting well on the test data set. Look at our RMSC, look at our train loss and our test loss, and looking at the graph, you can see that there's a difference in the graph. And also we have some results. I said we don't want to make this into some. If you can check our notebook, you will see the result of countries, and you can compare from actual and you see they were closer. And lastly, when we not deploy the model, actually, we deployed and created the app. Like we personally, like across the team, we tested it. So we put in the values of a country that we all knew, and we had the results. Then we put in those values. Then we predict. And after doing our prediction and look at the value, it was very, very much closer. I think the actual value was like 12.1 to something, and the predicted value was like 12.09, whatever. So just like a difference of 0.00 whatever, something. So from there, we knew that yes, the model is performing better. And we tested for several countries, Uganda, Zambia, as well countries. And I mean, it was doing well. So that was our metrics.
Okay, thank you very much. Thanks. And well done.
All right. Thank you so much, Peter. Charles, anything from your end?
Yeah, I think I'll answer most of the questions already, but I was looking through the source code repo. I don't know if you've basically committed all the codes or some things are missing, because you have some folder in the README documentation doesn't match the code structure in there. So you have data app.py, static model. I mean, did you git ignore those things, or are you still gonna check it in?
Yeah, so they were actually there. So what actually happened is that we in the deployment stage, so we actually deployed across several servers. So we spread the tags across the team, we divided ourselves into units. So we spread tags across the deployment units. I think we have 4 or 5 of that unit. So we deployed across different server, login phase, Streamlit, render, and different kind of. So looking at to beat the time and looking at the one that work best. So we actually didn't use like a repo, just like single repo for that. So in different repo I will use, of course, we just ignore some of the files. We do some of those things. We put in some runtime or sort of some runtimes or packages as well. So after doing that, we pushed everything to this particular repo. So the README, yeah, the README is still some kind of touches, but then we made sure it just aligns with
So
what we've done.
I just don't want to keep this going for too long. Are you gonna still organize the code base properly to match what you described? Because it's good to have a good documentation that match what you have in
Okay,
the.
yeah.
All right.
Yeah, so I'm going to structure the README. Yeah.
Thank you.
Thank you. Yeah.
Thank you very much.
All right, thank you so much, Charles. Biodu, do you have anything for them?
No, I think we should keep going. I've already, all of my questions and some of my thoughts have already been covered. So let's keep going.
All right. Thank you so much, Tim Bigan. That was a good one.
Thank you for
Dal
your time.
E, you're up.
Thank you.
Donald, Sunday Udofia, and Adewole Odunwa, your grace.
Is it me? The audio is very low.
No, the audio is very low actually. We need you to boost your audio, Donald. We can't hear a thing.
Okay, can you hear me now? Hello, can you hear me?
Yes, a little bit louder though, please.
Okay. Good afternoon, everybody. I'm here to present on behalf of the E-Group on the topic predicting malaria outbreak hotspots in Africa. As you can know, malaria is a menace to in the region of Africa, and then
Sorry,
today
please, can you increase your volume? It's quite low.
I'll increase my volume to the bed.
Or maybe your co-presenter can take over.
Grace, can you hear me? Can you take over from here?
Okay, the volume you used just now is perfect. Can you do that?
Perfect. Okay. Introduction to the topic is malaria is a life-threatening parasite disease that is caused by female anomalous mosquito. And basically what our project is up to is to predict the hotspot where we can predominantly get this malaria outbreak so severe in the region of Africa. So next slide. Next slide. And the major problem here is it's in spite of the efforts made by different organizations to exterminate the menace of this malaria, it's going to keep on coming. So the solution should be to find the actual hotspot where this
I think we lost your voice there.
Donald, we can't hear you. So I think Grace should take over, and we really can't see your screen any longer. Or is it just me? Okay. We can now see your screen. So maybe Grace should take over. Adewale Odunayo. Okay, what's going on? Should we come back to you? Dali, time is going and we can't wait for you to sort this all out. Yes, Argan, are you ready? Igodo, Uzodima.
Yes, I'm ready.
Okay. Can you stop sharing screen, please? I don't know who is sharing the screen currently. Please stop sharing screen. Get your acts together and you would present again. All right. Take it away, Igodo.
Okay. I don't know where I'm. So let me share my own screen. Uh, sorry, I'm sorry. I'm struggling with
I'm up now. Grace, are you there?
the interface. Is okay. No, sorry. Sorry, that's not what I wanted to do. Sorry. With Please pardon me. I'm struggling with the interface. I don't think I know what I'm doing.
Okay, should we come back to you? I think jukebox should go then. Malo Gonolo Matheka and Ilu Yomade Ayomide, are you guys ready to go?
Yeah, hello. I don't know if you can hear me now. I was speaking the other time, but no one was hearing me.
Okay, yes, we can hear you. Are you ready to go now?
Yes, let me
All
just
right.
share my screen again.
Okay, please. And this time around, please don't waste any time. We've already taken some of our time away.
Yeah, so starting from where it stopped, the aim of this project is to analyze the relationship between environmental factors, malaria cases, and also develop a machine learning model to predict the likelihood and severity of malaria outbreak based on the environmental conditions. So let's just move on. This is our methodology. So moving on to just exploratory data analysis, checking our data. Then we did the correlation analysis for the numerical table. Then I would like to dwell here from this side of the slide. The first one is the trend of malaria incidence over time. So for the data we just have for up to 2016, and we can see the trend of malaria. You can see back then, 28 to 2012, you can see the higher rates of malaria incidence. Then looking at the geographical distribution of malaria incidence, we can see that the concentration was between 0 to 10 latitude, that's the equatorial region, and these occur because of their humidity and their temperature. Now moving on to the spatial analysis, you can also see the concentration of malaria incidence in the western and the central region. Same thing with the clustering analysis. Now moving on to establishing a relationship between the environmental factor and the malaria incidence. This is why we have different machine learning models that we did. But that's not the goal of the project. The goal of the project is to leverage on AI model, of which we leverage on GAN, that's the generative model. So we have the CT GAN, that's the conditional tabular generative model. So this is it. So the conditional tabular generative mode adversarial network is a GAN model that we use to generate new data similar to the structure of the data that we have. And this was done because we want to increase the training data sets. So then afterwards, we match and we have a logistic model where we can predict our country. You can see we compare the data sets we have before and the one the city GAN generated for us. You can see that the data does not really deviate much. Then moving on to our deployment, I'm going to be showing our deployment now. So we trained it on the Streamlit app. So to predict country, and we have our, okay, it's loading so that I can quickly show that because of time. We have the basic drinking water, we have the basic sanitation services, we have those the population, rural population, urban population. So putting all the values as you like on these features that we have, we can generate our country. And predicting our country, we can see Cabo Verde. So we can see this is a model predicting country, and the goal is just to know that okay, if we have a focus of where the malaria incidence is severe, then we can know what to do and the intervention to employ in those country in Africa. Thank you.
All right. Thank you so much for that, Grace. So, do we have anything to say to them, Biodun?
Yeah, it's a good project. My audio was cutting in and out. Uh, all I did was just look through the documents that they've added. Overall, I think it's a good project. Unfortunately, I can't add a lot for the data right now, but keep up the good work and do some type of posting about this, especially because of how pivotal the topic is.
Yeah,
All
thank you
right.
very much.
All right. Charles.
Yeah, I think y'all did some good work here, but I mean, there's some factors that we can't control. So I know how it feels trying to present and things are not like coming up well. But I just want to know a little bit more about the RAG because it looks like y'all didn't build this tool from scratch. It looks like it's a RAG tool that you basically use to browse and upload files. Then you select the model that you want and set a temperature on it. Did you build this, or what's the implication of this, or what you're trying to get to with this stuff that you have on the screen?
All
Uh,
right.
who's doing my screen? Can someone talk to it on the group? On the team that worked on this?
Yeah, hello, I can't get your question. Is it a question or just
Yeah, I
an
mean, it's kind
advice?
of like a comment. The tool that you have in front of us right now, I want to assume that you guys didn't build this. It's kind of like your RAG tool that allows you to browse and select your data sets, and you select the LLM model that you want to use to inference against it, right? Can you explain what's happening on this dashboard or this chat interface you have in front of us?
Okay, if I get you right, you were talking about our model predicting country, right?
Yeah.
Okay,
No,
the
no.
model predicting country, we only use the features we have in our data just to have the model predicting country using the city GAN to generate more data.
Okay.
Yeah, there is no rag.
Okay. But sorry, I think I was looking at another screen. Yeah. All right. Thank you.
All right, thank you very much.
Okay. Does Peter have anything to say?
No, thank you. I think my colleagues have already said it all. Well done. Thank you.
Yeah, thank you.
All right. Well done, Grace. Yeah. All right. ESR GAN. Are you ready now?
Yes,
Igodo
thank you very
Zodima.
much. We're ready.
Oh, you're ready now. Okay.
Um,
Good.
okay,
Please.
so
Okay, when you're
the
ready.
topic of our presentation is actually unlocking potential by exploring the factors that would impact on student success globally or internationally. In the first section of this, I'm going to discuss about how we arrived at at the documents that we use to build our RAG application. So we basically wanted to
Sorry, Igodo, we
can you hear me?
cannot see your screen. Maybe I think you should make it in PowerPoint view. Thank you.
Oh,
We can't see
sorry, I'm
anything.
sorry. I forgot to do that.
All right.
Okay. Yes, I forgot to
And oh,
say
Grace.
that.
It seems she's the one still sharing. Okay, she has stopped sharing now. Okay, yeah, we
Okay.
can see you now.
How about now? Can you see me now?
Yes, yes, we can.
So we basically want to study the factors that impact on educational outcomes internationally across countries. In this study, we actually studied variables from 86 countries, and those variables are teacher and pupil-teacher ratio, annual teacher salary in USD, adjusted for purchasing power parity, then government expenditure on education as a percentage of the total government expenditure, and an index measuring the shortage of learning materials, really. And our aim is to prescribe recommendations and policies that will improve international education outcomes globally in various countries. So we collected our data mainly from the Organization for Economic Cooperation and Development and the World Bank. So we removed duplicated values, dropped redundant columns, and set every variable, every data point in the right format, and handled missing data as well as we could. Then we engineered two features basically. So instead of using PISA scores, PISA actually stands for the Program for International Student Assessment. Is actually a measure of a student's ability to understand maths, read, and understand science. So instead of having those three scores, we used one because all those three scores were collinear. They represent the same thing. So an average of all will still give you the same information. Then we determined we got a new variable called spending efficiency to tell how effective governments were in spending, or how efficient they were with spending their resources. And the first step we took was to do a sort of exploratory data analysis where we found the distribution, or measure the distribution of all the variables. And here you can see that PISA scores is more like a bimodal, has a bimodal distribution, which means that there are two modes or two top values. And that's that's guided us to understand that there are certain hidden features in the data that we need to further explore. And that's why we did an unsupervised machine learning process. Basically, K-means, we instituted a K-means algorithm, which I will explain later. So K-means was clustering was basically trying to pull out the different sections or different groups of countries based on their unique characteristics, and understand the characteristics or the reasons why those two countries are separate. So after using this algorithm, we realized that we can actually separate those countries into two groups. Most countries in Group A were the countries that really had high scores, and all their variables pointed in the right direction. They had low people-to-teacher ratio. They had higher salaries for the teachers. So we have countries like Australia, Austria, Belgium. So most European countries, North American countries, and East Asian countries were in the first group. Why countries in the second group weren't doing so well? We have South American countries, Southeast Asian countries, Eastern Asian countries, North African countries, and the rest of the likes. So here you can see that countries in the first cluster seem to perform better than the countries in the second clusters in almost every variable. The size of their classes were lower, the teacher's salary were higher. But here's the funny thing: the expenditure of the amount of money that countries that had higher PISA scores were spending on education was far lower, or was relatively lower than the countries who were not doing so well. So why would countries who have better educational systems spend less on education? And that's why we decided to do further analysis to find out how efficient those countries were with the way they were spending their resources. And we found out here that the countries who were in the first cluster, who had better educational structures, actually were more efficient. The amount of PISA scores they get for each unit of currency they spend was far better than countries who spent more. That's the countries who perform worse. So the poor performing countries probably aren't really efficient in the way they utilize their resources. And these are some of our key findings. Singapore, China, Korea, mostly Asian countries, and some European countries performed really well, while the bottom performers were mostly South American countries and some Southeast Asian countries and some Eastern European countries. Kosovo, Uzbekistan,
Sorry,
and all
Kuku,
that.
not moving your slide.
Am I not? I'm not moving it.
No, it's just stuck on a page.
Really?
Yes.
But okay, it's moving on my end.
Okay.
Is it not? Are you not seeing it? Or
Uh,
do I have to share?
okay.
Are you seeing my slides, please?
Yes, yes, we can see your slide.
Okay, so
Continue.
here, okay, so we have the two clusters. We have the correlations between the variables, teacher salary and PISA scores. So the higher the salary of teachers, the higher the scores of students in this study. So there's a strong positive correlation between teacher salary and PISA score. People to teacher ratio is kind of like has a negative correlation. So the smaller the size of the class, the better the performance of students. While government expenditure, like I said, this is a very unique phenomenon that we had to study, and we found out that even though the governments that perform better spend less, they are more efficient with how they spend, and that's why they didn't need to spend so much to get good results. Okay, so these are
Ugodo, sorry to interrupt you again. Your slide is not what I'm seeing. I actually assumed it was your slide, but this is your deployment stuff, I think. Please, direct us back to
really
your slide. Yes. So we can't
my
see the slide at all.
so it's this is what I'm sharing. It's let me minimize this because how about can you see my slides now? Hmm?
No, just a close-up version of what we've been seeing before. It's a
How
web
about
page we
now?
are seeing. Maximize your slides so that we can see your slides now. Please maximize it so that we can,
How about now?
yeah, we can. We are seeing your key findings.
Okay, did you see all these other slides?
No, we didn't.
Okay. I don't know if you can give me some time to quickly go through again because I thought you were seeing all what I was
Your
doing.
time is up unless maybe the judges need you to show your slides
So
while explaining
Hey,
show
them.
just
them.
go through it real quick. And
All
so
right.
Okay, thank you very much. Okay, so like I said earlier, I started by explaining where I got my data from and how I cleaned them up. So the final document, the document that we use for the rack system is actually a table of values of different variables, of the different variables we use for the study. And I mentioned here some of the analysis that we did. We we found out that the distribution of the PISA scores is bimodal, and that means that there are two modes, and that means that there's actually there's some hidden information from this distribution that we needed to explore further, and that's why we did a clustering algorithm. We did a clustering machine learning algorithm to try to understand the hidden characteristics of this PISA score value that we saw an abnormality. And we found out that you can actually group the countries in this study into two distinct groups, Group A and Group B. And Group A countries were countries who had better scores overall. They had smaller class sizes, they paid their teachers better, but here's the thing, they didn't spend so much on education as much as the countries that didn't do so well. And we try to understand this abnormality. Why is it that countries who spend less on education have better education outcomes? And so this graph here kind of like tries to compare the two groups or the two clusters on the different variables of our study. So we found out that countries who spent less on education were actually on the lighter parts of this on these dots, and those countries were more efficient in how they spent their money, while the countries who were in the second cluster were less efficient. So it all comes down to finding out the right places to invest your money on or your resources on, and doing that effectively. So the countries in Group A were more efficient with the way they spent their resources, and that's why they didn't have to spend so much to get good outcomes from their students. And so these are some of our key findings. There's a strong correlation between teacher salary and PISA scores. As if you pay teachers properly, you're going to get better outcomes, better educational outcomes from students. If the sizes of the classes are smaller, if the people to teacher ratio is smaller and classes are more compact, you get better overall outcomes in your education or in the educational system of your country. And even though, so spending more money on funding education aggressively may not always give you the right outcome if you're not efficient with the way you spend your resources. So those are some of the findings we're able to deduce from our study. For underperforming countries, reduce the size of classes, invest in teacher development, ensure that there's access to learning resources, and improve your spending efficiency. While for higher performing countries, share best practices to the poor performing countries, address equity gaps, and promote innovation in technology. So I'm going to quickly go through the RAG system that helped us to come about most of these conclusions. So the LLM we use for our RAG application is actually Cloud Sonnet, but we created it in such a way that users can choose between Sonnet, Haiku, and Opus. These are all cloud models under Anthropic family. Then we use Google's generative AI embedding model, but also had an option to use Voyage AI, just to compare the both of them and see which one works more for us. Then the documents for our RAG system is actually a PDF file of the structured data on educational outcomes. So after we had collected our data, we had cleaned it up, we put it in a data frame and exported it as a PDF form, and that was what served as our documents. And our vector database was actually Facebook AI similarity search, and we used LangChain as the framework for our study. Now, these are the dependencies that we use to build our RAG application. So the structure of our code, we basically created a virtual environment and installed all the necessary libraries, passed the data, built the necessary prompts, and created all the necessary LangChain objects. And that was all we needed to do to. So let me quickly show you our AI assistants. Okay, so I'm having problems in showing this. Sorry, but anyway, I can take this out. I'm sorry, there's something that is blocking my ability to share this. And I don't know if you can help me fix that.
Okay, are you getting an error report or what?
No,
Because
no,
we can see your
okay,
AI,
so
your
here,
deployments. This thing.
so I'm going to run a really complex prompt and to show you how accurate and how effective our AI system is. So yeah, I'm going to ask it to use k-means using k-means algorithm group countries based on their PIA6 scores. Set k equals to 2 and then plot a map graph. Then plot line to show the clusters each country belongs to. So here you can see that you can select between the three models here, and you can adjust the temperature and the top P value. But I'm also going to show the performance metric of this application. That's how the time it takes for you to generate a response given a given input query. And if I run this, and it will take about 30 seconds to run and generate a response. And the beauty of our product is that, or of our tool, is that it generates the code and renders it directly. So we don't have to copy out the code and put it in a Python interpreter, or so to say, it renders the code output on the interpreter on my local machine directly. And that's what makes our product to stand out. In a few seconds, there should be a result. Okay, so that's it. So this is the progress bar. It's trying to right now. It's trying to render the output on the interpreter on. So now here's the output. So this is the output of our model. So you see, it's interactive in the sense that if I hover around it, it kind of groups the country I hover on into the two different groups of either cluster A or cluster B. So group one are the countries that have better overall educational structure, while group zero are the countries who don't have, as well as a good, that don't have a very good educational structure. So here, USA, Canada, Russia, China, all these are North American countries, all the European countries, and the Eastern Asian countries all fall within the top category of countries that have a higher overall average PISA score and whose variables are all in the right direction. Whereas countries in South America, in Africa, and in Southeast Asia and some parts of Eastern Asia don't really do so well. I can actually plot so many, I can perform so many tasks really on our RAG tool. It can do almost anything I ask it to do, and it doesn't make so many mistakes. There are very few bugs or code errors that it generates. Say, for instance, I ask it to plot a correlation graph, plot correlation graphs between the predictors and PISA score using Seaborn. Yeah, before I failed to mention, our last prompt took about 61 seconds, about a minute to generate output. That's because there was a lot of computation that had to be done for that to work. But this should take lesser time.
Are you there?
Yes, it's
Okay.
it's take a few seconds to render. Okay, it appears our model is taking a lot of time because of the complexity of the task that is given to it. But yes, so finally. So here it's unfortunately it pulled out, there was a mistake. It turns out that it couldn't render this output for some reason. Say it says here that plot is not defined, which means that there's probably something with my matplotlib library and my interpreter. But overall, this tool is actually very reliable and it doesn't always make any mistakes. I think that's all for now.
All right. Thank you so much. Anything to say, Yodun?
Yeah, so great work overall. I see the vision of what you're trying to do here. In your own words, is this a lab project for you, or what are you planning to do next with it?
Okay, so this product is kind of like as a standalone product, I think it's fairly okay. Perhaps we need to gather more variables, consider some other factors that would affect overall students' performance across countries, include more countries. Um, in my reports, I actually mentioned that we need to find a way to invite some other countries to join. As you can see, most countries in Africa don't even partake in this study. We don't have any. Nigeria is not really a part of this study. Most Saharan African countries aren't really in this study. So we can invite more countries to partake. India is notoriously not in this study. And if we can bring in more variables and collect as much data as possible, we can actually we can have a system that is far more reliable than what we have now. Even though what we have now is really good, mostly because we insisted on finding as many as 86 countries and finding data on those 86 countries. So when we had missing data, we didn't just stop there. We didn't just impute the missing values. We went ahead to source for those values and ensure that the data we collected is as accurate as possible. So in my opinion, I think this project can really have a lot of it has potential to be very valuable to countries and ministries of education and the rest of the likes.
Okay, so I would just share my own 2 cents, and you can use it as you wish. There are many tools out there today that are that are so robust that all they need to do is to have AI capabilities. If you go to any research university, they probably use some form of statistical analysis tools like HDSC, or a lot of these like very robust tools that they can technically have a feature or a component to what your built down is doing, or can even take you a bit further. Against trying to add participation to more tools, how about you consider publicizing your work? Having more countries participating in this data, I don't know if that's a problem that only you can solve, but having awareness and adoption of what you're creating is probably will be a lot more beneficial, and I can give you for a faster, longer roadway. It's what I recommend, or what I propose. But you can use that information as you like. I think what you're doing definitely is combining AI with some of the statistical tools that we got available. If anyone type this into ChatGPT today, they might not be able to do all of the modeling and all the rest, but that's the work that you're doing for them. But could another tool do it already? Could what you are building become an application that can then be frameworked into a broader, bigger solution? That's how I think about it. But then that's just what you said.
Thank you.
All right. Thank you so much, Biodun. Peter, do you have anything to add?
No, I don't have anything to add. I think it's already been said already. But other than that, I said good work, and hopefully you get to fix those bugs that tend to come up, especially in demos. But yeah.
Yeah.
All right.
So the truth is
Thank you,
yeah.
Peter.
We have a success rate of over 99%, really. Um, this we don't really run into any errors, mostly because Sonnet is really, really reliable. And we prompted our context in such a way that it understands what it has to do, and it's easy for us to render our output directly. So it's, I think, to a greater extent, the error level we get from this product is really acceptable, because 99% accuracy is really something we can work with in any system. Okay, thank you.
All right, Charles, anything to add to all of that?
I think I donated my time earlier, but I will ask you a quick question. Can you talk about this tool? And the tool that you're pointing to right now. So I see that you're uploading a data set.
Yep.
What's in that data set? Then you're selecting a model. What's in that model? So is it like is it I see it generating a bunch of code and it took a while to run. Can you just talk a little bit more about the tool that you're
Okay,
using?
so this tool, this RAG system basically takes in our data sets, which is a PDF file of structured data on the different variables that will affect, that would measure or that impact on PISA scores. PISA is actually a program for international student assessments. On It's a test that measures 15-year-olds' ability to reason in mathematics and science and in reading. So we try to study some of the factors that would affect that variable. So we collected all our data and put it in a PDF form. And that's the document that we fed to our rack system. So the rack system definitely has several variables that we're trying to put together with LangChain. LangChain is actually the framework that allowed us to build the system. So Cloud Sonnets is the model, rather Cloud, because you can select between Haiku, Opus, and all of that, and it will still give you results. But I'm using Sonnet here because it's the best and the most intelligent of all three. Now we embedded our documents with Google generative AI embedding model. And that embedding model really works fine, even though we use Voyage sometimes, but we decide to stick with Google because it's fine. It works fine. Now, our vector database is Facebook AI similarity search. I would prefer that to Chroma, and it's all good. So, but for
Any reason for
digital,
preferring it to Chroma and Alloy DB?
yeah, what do you say?
Any reason for the preference?
Well, yeah, mostly we realized that when we use Chroma and we confirmed or we compared our model performance metrics, that's the time it would take us to get results. And we compare that to Facebook AI. It seems as though Facebook AI scaled better for us. And even though our document isn't all that large, but for really huge prompts, when we give it really huge queries, it's called that Facebook AI summarized search does an overall better job for us than Chroma. So that's why we stuck to Chroma.
Okay, thank you.
Okay. So I don't know, is there any other? Yeah, then we actually included a component that will make the rack system memory history aware. So that way it can actually retain previous conversation and make reference to those previous conversations. And that way it retains context. We don't have to start afresh whenever we want to get it to do something. It's um it's kind of like retains memory. So I don't know. So I guess that's all for now. Thank you very much for your inputs and your advice.
Yeah, that's it from my end. Great job. I'll follow up on the source code and try to look into this a little bit more. It's very interesting.
Yeah, sure. Thank you very much.
Yeah.
Thank you.
So I'll be picking up from where my colleague stopped. So the next group to present is going to be Jukebox. Jukebox, are you ready for us? Jukebox, the presenters for Jukebox, are you available?
Yeah, this is Vishwanath.
Okay.
Yeah.
All right.
Our lead has actually our lead has dropped 1 hour before the presentation. Is not presenting. So as an assistant lead, I'll be presenting the part of this. Okay. Yeah.
All right. So go ahead.
Ahmed, you can start. Yes.
All right, good afternoon. Good afternoon, everyone. Good afternoon, Amoye. Good afternoon, judges. My name is I am Neil Omade, and I'm presenting alongside our assistant lead. And our topic has been on leveraging AI to enhance food security and access in Africa and Asia. First, I'll start by explaining that food security is the state where all individuals can have access to adequate, safe, and nutritious food that will meet with their dietary requirements. And there are four key components that these consist of: the availability, the accessibility, the utilization, and the stability. So really, our project is focused more on the availability and accessibility, because of course, both African and Asian continents are facing a significant challenge in achieving food security, with millions experiencing hunger and malnutrition. And we believe that if we can leverage AI, we can enhance this food security and make it more accessible. So the aim of the project is actually to to um, to bring about sustainability and resilience in the food system. So okay, you can move on. Next slide, please. Okay, so this is our project workflow. We had our data collection from the Food and Agricultural Organization of the United States. We collected both the change in temperature data, production indices, the crop yield, and then from the World Bank group, we obtained a precipitation data set. And of course, we ran this data through uh, several applications to at least rank it out, make it cleaner. And before the exploratory data analysis and visualization, followed by the feature selection and then the modeling and evaluation. So you can move to the next slide. The data preparation, we actually obtained the data set for 98 countries from both Asia and Africa. And then data set was focused on the crop yield, the production indices, and then the environmental factors. So the process included loading and inspecting that data for missing values and then categorizing the crop yield data so that we can remove any irrelevant categories. Then the initial stage of our analysis, we performed the exploratory data analysis on the temperature data and then the crop data. So for the crop data set, we had a number of descriptive statistics to check out the integrity and then transform it into a long format. Then we just using this profile reporter, we're able to give a detailed report, to generate a detailed report from that temperature data set. Then we were able to integrate that temperature and the crop yield, because we wanted to explore the correlation between the temperature fluctuations, the precipitation, and then the agricultural productivity. So with that, we're able to categorize to the low, moderate, and the high temperature, and then we're able to find out which country has the highest yield, what are the products that have the highest yield, and also I think we will continue from there on the features and the modeling. Triaja?
Yeah.
Yeah, you can continue.
Am I audible?
Yes.
So first of all, the merger dataset has this the first columns like country code, country category 2000 years. So I have melted the years column of temperature, crop yield, and the rainfall into these three into one column each. So then I have created I have feature engineered and created new columns which are change in temperature and average temperature for each country of all the crops included. And I mean, I have labeled and added label encoding to the countries and categories. Here, categories are crop types, which are maize, barley, livestock, and animal products. So after training this model, here the we got more feature important. We have more feature importance to the rainfall and just rainfall and the change in temperature. So we have selected this both features for the crop yield. Here we are predicting the crop yield with respect to rainfall and the change in temperature. So we have used 6 different types of ML algorithms. So we got random forest as highest accuracy. I mean, good fit score, which is 96.85. So here there is a large, large number in the mean squared error. This is due to small error. Uh, small errors which are in large quantity. As you can see in this graph, which there are very small errors, but there are in large quantity. So we got a high mean square error. So that's it from our side. Thank you.
All right, thank you very much. Over to the judges. Charles, please, do you have any comments or questions for the team?
I can go next after this, so I'll pass. I'm looking through the slide real quick.
Okay, Peter, do you have any questions or comments for the team?
Yeah, once again, good work. Can you shed some light on any of the challenges that you faced collecting data for the work that you did? Because one thing I'm part of, a few of these sessions, and this specific malaria, so it's an issue with food security has come up once, I think, in the past, and this data collection has been something that's, been talked about a bit. What challenges did you face collecting data?
So as Ayomit said, we mainly focused on the availability, which is production side of the food security. If there is more production, we thought that if there is more production, there would be more access for food to the people of Africa and Asia. So we got these data sets from FAO stats. It has production indices, crop yield, and the change in temperature dataset. So, but we struggled trying to get the average rainfall or rainfall for the rainfall feature for the crop yield dataset. So at last, we have found it in the Bank Group's World Bank Group's website.
Okay, so alongside that, also one of the reasons why we have to basically focus on just availability and accessibility, and not the other two components, that's the utilization and service, was actually because of the data. Because the problem of food security isn't just about the availability, but making it consistently available. So getting the translation data and then harmonizing all of that data into one was a bit of a challenge. So that's one reason why we had to actually just stick with, okay, how available is this food and then how accessible is it, and without focusing on the utilization and the sustainability.
Okay, thank you. And question is, I noticed you've done analysis using up to 6 different models here, methodologies. It's not entirely clear which one you ended up using. Was it the decision tree or the random forest?
Random forest. It's random forest.
Okay, it was the random forest. And obviously that's just because it has the best R squared score. What other criteria did you use to distinguish that between the decision tree and the random forest? Because they both look like the two best in terms of the metrics you provided here. I just want to understand why you settled on the random forest.
Because it gives best good fit score than the decision tree, and also it has the best mean square error. I mean, yeah, it's just the good fit score. We just use the good fit score and took the model. I mean, algorithm.
Okay, thank you very much, and well done again.
Thank you, sir.
All right. All right.
If you don't mind, while you're still you took the screen off.
Oh.
My question was centered around your model selection. So did you manually run all the 6 different models from linear regression to random forest? Or, I mean, there's a way you can basically use a tool to you feed in your data and you run it against all the 3 models. So then you select, and you go through multiple iterations. Then you select the best performing model. So I think it's called something like AutoML in the Windows on Azure, but there are tools to do that. So did you manually run each of these models, or you used any tool to like?
No, we haven't used any tools. We have created a pipeline for we have created a list for each model, and we have created a pipeline and did it manually.
Oh, okay. So you basically, when you say pipeline, what do you mean by pipeline?
We have created a function which could give, if you run it, it would give the accuracies for each model.
Okay, and how many iterations did you run for each model?
We have run one time for each model, but we have did after we got the results, we tried to do the hyperparameter, tuning the random forest, but it's increased just by 0.00 percentage. The good fit score has increased by 0.00 percentage. So it's nothing to mention. The hyperparameter tuning. Yeah.
Okay. All right. Thank you. Great job.
Thanks.
Yeah.
All right. Thank you very
much. Thank you so much. So does Biodun have anything to say about jukebox present?
Nothing from me. Thank you.
Okay. All right.
Great job.
Thank you. Ludwig, over to you. Courage Siame and Muhammad Balogun. Are you there?
Yes.
Okay. You can share your screen and begin. Hello.
Yeah, I'm having a bit of a problem sharing the screen.
All right. Since you're having problems, maybe we should move on to the next group, Picks to Picks. Abdul Kabir Badru, grade 1, Ibiduni. If you guys are ready, you can begin, please. All right. I think Ludwig is here. Abdul Kabir or Ridwan, I don't know which is here, but please, can you start already? We can see your screen. Ridwan, you can start. We can't hear you. We can see your screen, but we cannot hear you. Please, can anybody else hear what Ridwan is saying? Because it says he's speaking, but we
can't hear him. No.
No, we can't hear. The is ready though.
All right, Courage, please, are you ready to go?
Yes.
Okay, please, Ridwan, stop sharing your screen.
Hello. Okay.
Is anybody here? Courage, Ridwan, who else is there, please? Okay, Courage has started sharing screen.
Good afternoon, and I'll be presenting for Ludwig. So, for our project, we are predicting conflict hotspots in the world, and we got a data set from ACLED. We got 6 regional data sets, and let me just read the project overview. So, we recognize conflicts and violence have significant impacts on societies, economies, and international relations. We are going to leverage the storytelling power of data analytics and predictive ability of machine learning to identify regions at high risk of conflict. Let me just skip this one. Our data set is mainly political conflicts. So we used some predictive models as well as the integration of LLMs to create mitigation strategies based on the output from our predictions. And we believe that by doing this, we can assist policymakers and humanitarian organizations in developing resources more effectively and contributing to academic research on prevention and peace building. So moving on to the problem statement, let me just skip this. Okay, the problem statement. The increasing frequency and severity of conflicts around the world pose significant challenges to global peace and stability. Despite the availability of vast amounts of data, current predictive models often fall short of accurately identifying potential conflict hotspots due to the complexity and dynamism of socio-political factors. Moreover, while large language models have demonstrated remarkable capabilities in natural language processing and data interpretation, they are not fully integrated into conflict prevention frameworks. This gap underscores the need for innovative approaches that combine analytics and machine learning to enhance the prediction of conflict predictions, the precision of predictions, integrate LLMs to generate mitigation strategies, ultimately aiding policymakers and humanitarian organizations. So moving on to the existing solutions, let me just skip time. So this is our approach. We've begun by collecting the data from ACLED. And as I said earlier, the data is purely political conflicts based. So we collected the data, we did exploratory data analysis and wrangling. And the data set we got to doing, they were separate from the 6 regions. So we had to aggregate them and then merge them. After which we did a pre-processing. Under that, we also had the feature engineering. We proceeded to build and train the random forest model, evaluated the model's performance, and also deployed the app on stream. So this is our data under exploration. A second, please. Okay, so the first, under the EDA, we performed some researches and came up with some questions we wanted to answer using the questions, using the data set we had. So the first question was, how has the frequency of conflicts changed over the years? And per our observation, looking at the plot, the first plot, it's depicted that the number of conflicts appeared to have increased from 1997 to 2024, with a notable spike in 2020. So this is the graph predicting that. And also we have this section shows the counts of the event types, the subcategories, the countries, the year, the perpetrators, and then the victims. So there has been about 2 million casualties of conflicts or victims of political conflicts across the 6 regions we collected. And under that, we have the event types, which are the main influences of, or the main factors that incite these conflicts. So we have the battles, violence against civilians, explosions, and then all that. This is graphically represented here. And let me just proceed to the. So we have the machine learning model. The modeling part, we identified the problem, collected the data, evaluated feature engineering, select and train the random forest model, evaluated, and then deployed on a streamlet. So this is the result of our modeling. The predictive model for conflict hotspots used was random forest classification algorithm. It was chosen for its ability to handle complex data sets, and the data set was split into 80-20, which is the 80 for the training and then 20 for the testing. And key features included the fatalities, log transformation fatalities, which was a new column created, and we encoded some columns to aid in the modeling. Okay, so the model achieved an accuracy of 85%, supported by metrics like the precision, recall, and F1 score. So that's the model there. We also had a feature importance analysis, which highlighted the region events, interactions. And the model also demonstrated potential for practical application by effectively generalizing across regions and conflict types. So this is our LLM implementation of our project. So this is our Streamlit web app showing, okay, the headline is the conflict data analysis and mitigation strategy. So this is going to, this app is going to analyze the conflict data we feed into it using the random forest model and generate conflict mitigation strategies using the LLM, which is the generative AI model. So first we'll need an API key, and then you drop or you, sorry, you upload the data sets here, and then we perform, just a second. So when you upload the data set here, the conflict data, it's going to go through some stages. It's going to pre-process. After pre-processing, it's going to run the random forest algorithm, then use the features selected to come up with mitigation strategies to prevent the conflict, like mitigation strategies for controlling and like reducing the occurrences of conflicts across the regions. I think we're having an issue with the data set. It's too large, and reducing it to it brought about some errors, so we can't implement or show how this interface is going to work out. Because I think that's it.
All right. While you're doing that, we can hear feedback from the judges. We can get feedback from the judges. Charles, what do you think of the project?
I think it's impressive. So I was gonna try to understand how this last stage work, which is what my question is gonna be centered around. Let me see. So can you talk about some of the challenges that you ran into initially? And while you're doing this, someone else on the team can take it up. During the process of setting things up, I know you went through the data preparation, data discovery, and all those phases. Can you just explain the challenges? Because it's not like a straight road like you have it on that graph. Everything looks nice and dandy, but that's not the reality. You run into a bunch of headwinds. Can you go through that? All the things you do to prepare your data and get everything right.
Okay, so the data set we got them from ACLED, and they were individual data sets from different regions across the world. So we had to individually download those data sets and then merge them. we created a new column named region where we categorized each data set. Let's say we downloaded this data set from Africa, so we put this in the column Africa, and let's say Asia or the Middle East or anything. Yeah, that's how we aggregated the data and we sorted them into a different column called region. So using that column, we are able to tell which kind of data we are working with. And that has also helped to it has helped to how do I put it? It has helped to individually like query the data to know more about each individually. It's not running still. But what this is going to do is it's going to after uploading the data, it's going to pre-process and then evaluate the model, and then based on that, it's going to give us a plot of the feature importance. Then what comes after is the LLM, which is going to provide some mitigation strategies, or let's say recommendations on the regions we input. So it would have been nice to actually demonstrate that, but since we are having this issue, it's like all I'm saying is actually meaningless. So
Question though, you said once you upload this,
yeah,
well,
once we upload
it,
the
it, it creates
asset,
it creates an LLM.
yeah, we created an LLM.
No, I thought you said this process creates an LLM. Oh,
No, we already have that with a prompt ready. So once we are trying to mitigate conflicts.
okay.
So it's going to take a region. Once we upload the data set, it's going to take a region or the region we selected, and it's going to look at the event types and come up with mitigating strategies to reducing the effects of conflict in that region. I think we're having issues right now. Demonstrating would have been a bit easier to see.
One thing you can do, and this is more for everyone as well, is like, why not try to pre-record this before the presentation so that you can have the video embedded on your slide. I mean, doing live demo may go a little bit crazy, but recording it may be.
We actually implemented the LLM in the notebook.
I mean, you should record your screen
Okay.
to your slide. So in order to get going, just record whatever you've have working on your local and send it to Mercy. We'll basically review it.
Okay, sir. Thank you very much.
All right, thank you so much, Charles, for that. Bilton, do you have anything to say to them?
Hey, so here's what I would just say. The idea, and if this idea truly comes to fruition, it's probably will be one of probably the best ideas that I've heard today. Well, obviously, we'd love for this to work and see how it all works. But I think what you have here is something that's truly that could be deployed in multiple scenarios. All of the questions that Charles had were questions that were on my mind in terms of like what is like the core architecture of what you're doing. This is a practical application of AI. It's a practical application of ML systems. And the idea is great. I haven't seen the execution come to life. And I'm hoping that all of that can probably gel in like a pre-recorded video when you eventually have it. But this is good. That's all I have to say for now. And you should keep working at it because so much that I can see applications. A lot of my commentary has all been around applications of this because there's so many people doing AI systems, but there really and truly is no monetization path. Just seems like a way to throw money away. Like I see this as like something that could be easily deployed in organizations. So you have a good partner in someone like uh, someone like Charles, because I think Charles can help you solidify your idea. So I think it's probably a good next step. There's so many ways that you can can leverage this, what you've got right now going forward.
Thank you very much, sir.
All right, thank you, Biodun. Peter, any contributions?
No, none for me. Thank you.
All right. Okay, thank you, Courage. That was cool. Picks to picks.
Yeah, we're ready.
You're ready. Okay. Abdul Kabir and Ridwan. All right.
Yeah, hope you can hear me now.
Loud and clear.
All right. Good everyone, my name is Ridwan Ibiduni from Peace to Peace. I'm here to present our project titled Synthesizing Realistic Wildlife Images for Conservation and Education using Generative AI. So to start with, we are motivated by the research work the data set that has been collated by the International Union for Conservation of Nature Red List that have in it's a catalog of over 79,000 species of animals that are labeled as extinct or they are vulnerable to extinction. And of course, we also explore another catalog that monitors animals that are not in this category, that is called Living Planet Report. And compared to the IUCN Red List, is only about 4% that is covered in the Living Planet Report. So we have a lot of animals that are classified as, prone to extinction in the nearest future. So we want to create a model that will help us, keep tab of this type of animal that are probably going to be in extinction in order to preserve our biodiversity and ecosystem in general. So we are interested, we actually explore some species in particular to build our model. So in our model, we are building a text to image model that is going to take a text and tends to give an image. But the method we are using is actually to retrain to fine-tune a pre-trained model using some sets of data sets based on the catalog of data that is found in IUCN. So we explore some literature to understand how this has been done in the past, and then the concept of GAN was also explored to know how to implement this. So our proposed approach, as I've said earlier, is to use a pre-trained generative model and use a concept called fine-tuning, transfer learning, a type of transfer learning, and then so that we'll be able to leverage the training that has been done on that pre-trained model instead of training from ground up, and use that pre-trained model to solve our own, to make it specialize on our own particular problem. So in that case, we are using this stable distribution model using a technique called Dreamboth to build the model. So because we want the model to be able to identify different environments and different species, so we specifically take three ecosystems, the aquatic, the terrestrial, and the aves. And these are the animals that we have there. Some of them live in the water, some on land, and some of them flies. So using Dreamboat technique is a kind of very advanced, very efficient techniques, because in this case, we don't necessarily have to put a lot of data sets in our model. With the Dreamboat technique, we can use sample data set like 3 to 5 to fine-tune the model instead of using a lot of data sets. So in that case, the first thing we did was to get our data set ready by putting them in separate folder, and to make sure that they are of the same pixels based on the pixel that the model was trained upon, which is 512 to 512 pixel that the stable division model was trained upon. And of course, we use a pre-trained weight that is deployed on Hugging Face, and that is what we use. That is what we actually fine-tune with this data set that we have. So these are some of the outputs that we get. we are considering, we actually trained, we fine-tuned the model using 3 sets of animal. We have, the first one is called African golden cat. We can see the real and the generated output here. And the second one is this white-backed vulture with the real and the generated output here. And the African manatee, the real and the generated here. Of course, we now want to test the capability of the model to generalize to new, animals, new vulnerable and extinct. I mean, those that are classified as vulnerable or they are close to extinct animal with this type of points. Then we can see the comparison of the output of the model to see if it's very close aligned. So I'm going to show you a video demonstrating the implementation of the model. Of course, these are all, prompts that, or images that the model was not trained upon and is able to give classification as close as possible. So moving on, from our results, we can see that the model is able to produce images that is very close to the real images that we have. And of course, it has ability to generalize to other species that it has not seen before. Of course, we have limitation in our implementation. Most importantly, we had to scale down to a very small size pre-trained model. The one we are using is small size compared to using extensive one because of the limitation of GPU and the rest of them. And of course, the model is not also perfect in its output. It has some challenges predicting or giving a very perfect output. So our hope is that this particular model will help in the conservation and creating a volume of data set for in this kind of problem, as animals are they are dying away. This type of model will be used to preserve this category of animal and is going to serve as benefit for public engagement in future. So conclusively, we hope to continue scaling this project by improving or adding more species that it was not trained upon before, instead of the 3 category that we use on it, and also make it publicly available so that people can continue working on it and help improve it. Thank you for your listening attention.
All right, thank you so much. Biodun, what are your thoughts about this?
Oh, great idea. Great implementation. I like everything you've done. I would say though that over having been part of the Hamoye panel for over the years, I've seen iterations of using wildlife imagery happen. I'm glad that you're finally trying to apply a little bit of AI to it. This is also an area that I think is very applicable in terms of its broad use to the world. I actually would take my imagination one step further. Consider how you could use different additional data points, maybe additional data points like what are some of the characteristics of a particular type of wildlife being in a specific place, and how can you use machine learning models to detect the possibility of a specific type of animal being in a specific area, or an animal that we thought was already extinct, just by the characteristics of what's happening in that environment. I really like what you've done. I would save some of my commentary for the very end of the presentations, but I do like how all of the students, all of the graduates from the Hamoye cohorts have been finding different applications of AI, and I think this is a great one too.
Thank you.
All right. Peter.
Yes, I just have to echo the sentiments there. It's amazing to see the way things have been changing over the years, and you know, it's nice to see this in this form. I was thinking about one other application. I was watching television the other day about this whole issue they have in Africa about people who come to poach animals and stuff. So there's tons of potential for this kind of the concept and idea you guys have put forward. And just generally, what sort of challenges did you have while you guys were sort of working on this? At least this year, did you have any issues with data or any of the optimizations?
Yeah, definitely. This model, for it to actually work, it can work on any lower memory CPU. For instance, it can work with CPU. It has to work with maybe GPU, and GPU is restricted, especially if you have financial constraints. So we wanted to try a more advanced model like DALI, or another one that can produce a very good image and give me good output, but we are restricted with that GPU constraint. Also, deploying the model online also requires it to run with GPU, and that's not also possible without financial commitment. So basically, the GPU constraint is something that does not allow us to use as many different characteristics, different species as we want, because we now strategically chose the species of animal that are in different habitats, so that it's going to capture the one that is flying, the one that is inside the water, and the one that is on land, basically. So just to minimize the workload on this particular model. It would have been better if we have a very good compute power, or we have the financial commitment for that.
Thanks for the explanation. Once again, well done. Thank you.
Thank you.
All right. Thank you, Peter. And Charles, any inputs in this?
Yeah, I think you guys did a great job. I think I like what I'm saying. So basically, you're generating all these synthetic images to augment the existing data that might exist. So I just want to know a little bit more. I don't think I saw the source code. I've not checked it yet, so we can share it. But basically, what you're doing is you're pulling a model from Hugging Face. You basically use that model, give it an input of a basic image, and you tell it to generate a synthetic form of it, right?
Yes, definitely. The model was pre-trained on some image we have assigned to it, and the code implementation actually shows the data set that we use and the generated one in more detail, and the code in more detail. So training it on this type of species, like I've said, three habitats, then is now able to generalize on different animals that we have not trained it upon before. So I think.
And you use a GPU for the training, or
Yeah, GPU.
What model did you use for the training?
And runway stable diffusion is a small byte stable diffusion compared to the bigger one, I think.
Okay, so based on what you saw, did you at any time created a unicorn, like something that doesn't really look like what you expected?
Yeah, definitely. The model actually mismatched. It made some error in its prediction, because if I want to do on live presentation now, the model normally have maybe 4 outputs. And I think the output of the model tends to improve with time. The first one might not be as better as the second one, then and so on and so forth. Then we can also tweak the hyperparameters to make it perform better. For instance, we have the gradient scale and some other thing that we can tweak to make it perform better. But in the code implementation, I have list of all the generated images, 4 of them for each of the animal we try it upon, and the data set we use to train it. And I think the explanation of the code, the GitHub repo itself is also there. I will share it in the chat now.
Okay, so and if you use an auto sample animal, something that it was not part of your training set, and you run it through the model, how is the result looking like?
Yeah, it's pretty fine. It's pretty very close. I have some example on my slide that I showed now. It predicts very close to the real image. It performed very well.
Generates or predicts because
As in it generates, I mean, it produce images that is very close. Just look like the real image that we download from the internet.
okay.
It produces real image, yeah.
And to follow up on that, did you, just out of curiosity, try to feed the synthetic image that you generate back into the model to see what comes out of it?
Not really, because our goal is to use, I mean, from test generate image. So we are doing a text to image model, basically. So we just give it test. We must have trained it on image, but we don't actually do the other side of using the generated one to retrain it. We don't do that actually.
Yeah, because
It might be something we can explore.
Exactly.
Yeah.
Because if you start with like small sample of input images and you get enough synthetic images out of it, you can feed it back in you to generate more images, I would think.
Yeah. Yeah.
And quality will be good enough as well.
Thank you. Yeah.
Yeah, very impressive. So what's the next step with this one? Are you guys looking to do anything else with it or?
Yeah. One of those things that I think I will want to do with it is to have a publication with a write-up that we've done here, because I think there is no particular research work on, just not keeping the animals that are called extinct or that are vulnerable on websites. We need a model, a generative AI that will be able to keep track of these data sets for future purpose. So I don't think there's a particular research work that I've looked into building, fine-tuning model to do that particular job. So think of publishing and think of deploying the model on Hugging Face space. That requires a GPU computation. So, and from there, open it up to people to contribute on how to scale it beyond the 3 species that we have used now.
Okay, awesome. Good stuff.
Thank you.
Yeah. Great job. Yeah.
Thank you.
All right, thank you so much, Charles. We'll be moving to the final and 8th group, T5. Adesonya, Oluwaseun Michael, and Jival Shah. Are you online?
Hello, ma'am. Am I audible? Can you see my slides?
You are audible and we can see your slide.
Thank you, ma'am. So we are group T5 and I'm Jival Shah, the project lead for this group. And today our topic is investigating infrastructure deficit in Africa using generative AI. Our team composes of me, the project lead, Michael, the assistant project lead, and you'll also find the list of other active members here. So now our problem statement. Africa faces significant infrastructure deficits across various sectors. This hinders its economic growth and it also hinders sustainable progress in uplifting the poorer regions of society. If unaddressed, this issue could have severe socioeconomic consequences and this could impact millions of people. What we have done is leverage advanced AI methods and generative models that can provide novel insights to tackle these challenges effectively. Our approach includes defining the problem, collecting data, exploratory data analysis. Then we used indices weight prediction, designed the chatbot, and we've deployed chatbots both locally and on the cloud. And finally, we've done documentation and reporting. Moving on to the dataset description. So our dataset has information about 54 countries, and most of them have information for 2005 to 2022, except one country, South Sudan. Our datasets include Transport Composite Index, Electricity Composite Index, ICT Composite Index, Water Service and Sanitation Index, and the African Infrastructure Development Index. Now I'll be handing it over to Michael, who will explain the exploratory data analysis to the audience.
Okay, so thank you for that, Javel, and hello to our judges and to our listeners online. So our missing data is limited basically to the country South Sudan only, with the data factors showing here, with the missing value just on about 0.8% only, and it ranges from 2005 to the year 2013. Next slide, please. So our descriptives, as you can see, we have a skewed data set here for the transport composite index with a mean value just on about 10%. And for electricity, also skewed to the right, and we have a value similar to that of the transport composite index, just on about 10% as well. Same for ICT and explosive move in the year 2010, slightly skewed, and the mean value ranging around 19%. And for the water composite index, which appears to be evenly distributed, the best among all the composite index, has a mean value around 65%. And finally, our AIDI, the total summation, which is also skewed, and we can see that that's ranging on a 20% mean value level. So top 5 countries and regional analysis, we can see that the best performing region is Northern Africa. And also we can see that the best performing country is Seychelles, as we can see on our chart over here. So now there's an equation that ties all that's the data set together, shown just above the evaluation there. And the weight, we had to predict this to help us understand this data set properly. And when we did the training, what we realized was that the linear, bridge, and lasso did not suit this analysis because of their value did not give us the value 1. So we chose that's the random forest, and we improved on this on the next slide. I went through this model enhancement, and we were able to generate these weights accordingly with our values there. And we were able to improve the model to the 92%, as we can see there. Could you go back, please? And we made a country prediction, which was similarly close to what the actual value is for the country Nigeria, shown with our Python code below. Now, leveraging Gen AI, if you move on to the next slide, we developed 2 bot applications. That's an analytical bot and an informational retrieval chat bot. We have a demonstration of these 2 bots on the next slide. So here's a demonstration of our analytical chat bot where we feed in the data set into our database. And we prompt this with a question based on our composite index data, and we are able to generate a text and a graphical based output. So also we have a QR code there that you can scan that gives you access to our bots as well. So waiting on the output, we should have that, and there we go. So that's our output, and I'll be handing over to Jibal to summarize this presentation. Thank you.
Yeah, so we also deployed another bot locally that uses the OpenAI model, and it used our information in the research paper as its base. Here, you'll be able to see the demonstration of this model as to how the questions are processed and how we get the answers. So here we've sent in a question. Now this will do a similarity search in a vector database. And here you can see the corresponding answer that has been displayed from a research paper. And this has been deployed locally. So this is about it. We've developed 2 bots that will allow us to get different types of insights. One will allow us to get numerical insights, whereas one will allow us to get more broad insights about the information contained within our research paper. We thank you for your attention, and we welcome any questions.
All right, that was cool. Thank you, T5. Peter, what are your thoughts?
Yeah, again, another very good presentation. I think barring all the technical difficulties today, the presentation has been very good, and this has kept up with it. One question I had is with the chatbot you have developed in, I know you showed the one that integrates with OpenAI, but did you have a demo for the other chatbots that you generated, or was it just the OpenAI one that you?
We have two chatbots. So one is with the Grok API. This is the OpenAI one that we showed. So we made two chatbots because our goal was to understand the infrastructure deficit. So we found out that some chatbots are better at analyzing a numerical data. So they'll give you really good predictions on numerical data. But if you ask them to make a broad prediction of what that data means, they flunk at it, basically. They aren't very good at it. So what we did was create our research paper and add in all the insights from the data. So for example, what does this growth rate mean? Okay, what does this mean? And we had other insights as well from our EDA notebook. It's a very big notebook, and that we fed into our OpenAI chatbot. So its function is basically to understand what it means, what the growth trends means, etc. And then it will give us an output. So the first one is the one we deployed. This one, the Grok AI one, is the one we deployed on Streamlit that is accessible to everyone. The second one isn't because we were using the OpenAI trial credit and we are close to exhausting it. So a lot of tries would definitely run up the bills.
Okay, thank you very much. And once again, well done, guys.
Thank you.
All right. Thank you so much, Peter. Charles, you have anything to add?
Yeah, I think Peter basically touched on some of the things I was going to talk about. So about great presentation. But one thing I want to talk about going back to, you say you had two different kinds of bots. One for information retrieval and one for data analytics. So I mean, one thing, it's more of a suggestion though, but one thing you might want to look into is building this as an agentic workflow where you can have multiple agents that you can talk to, and those agents would do each of these functionalities and combine the results. So it's something that is getting a lot of traction out there right now. So for this kind of use case, I think it's might be something you want to look at down the road. But overall, great stat. I think you can build on it and move it to that level. And it's going to be a lot more interesting.
Thank you so much. That is something we are looking into about how we could integrate these chatbots. So what we've done with the OpenAI model is it's a different something we're working on is use some open source models like Qwen2, which have lesser parameters and slightly less accurate. But you can usually use Hugging Face's API key and get it done for free. However, for this project, we wanted to show the more accurate model. But using that free one, we might be able to integrate these two and make it more scalable.
Yeah, make it more scalable and just leverage some of the LLMs out there that do the reasoning for you, and you can just execute all the workflows based on the results of all the reasonings. Yeah, but I think this looks great. Great job.
Thank you so much, sir.
Thank you.
Thank you, Charles. Does Biodun have anything to add to all that has been said?
No. I think everything that I've heard so far aligns with my thinking, and great job with this again. I'll give my closing speech. I probably will talking about some of the general comments that I have for all the projects that I've seen so far.
All right. Yeah, moving close to doing that. Thank you, everybody. I know we are all heaving a sigh of relief. Oh, thank God it's over. Thank God it's done. Thank God we got it out there. Good job, everybody that came to represent their teams. Well done. All presenters, and to those who showed up to cheer them on, thank you also. Any final words then for our interns regarding their performance? I would be asking Peter first.
I think you're very proud of the work you've done. It's taken a lot from you, but you've also given back, and I hope you've all learned a lot. And I've learned a lot, certainly being part of this. One thing I'll just say is don't stop at where don't say, oh, you've done your presentation and that's where I'm going to take it. No matter where you end up, I would highly encourage you to seek the next level, try and figure out what you do next with these solutions that you've developed here, and continue being, be open-minded, especially about the cloud. I'm a very, big advocate for cloud anything. So a lot of the sort of, limitations that were highlighted in these sessions today was like, compute capacity, costs, and all that stuff. So try and figure out the way that you can make this more adaptable, integrate solutions that can be, cheap and, cloud focused. I think that's what I would, the kind of feedback I would give back. And so, yeah, once again, well done. And thanks for allowing me to be a part of this.
All right, thank you so much, Peter. Charles, what would your final words be for our interns?
I think, I just want to commend you guys for like hanging in all the way till the end. It takes a lot of grit to get to this stage. Sometimes we present all these things and it looks easy, but I know it probably took a lot of, countless number of late nights and trying to like work with people to make this happen. So I understand what goes into like doing stuff like this, but again, it's not the end. Those who generally succeed in this field are very persistent and they're very focused, and you always need to learn it. Keep on learning what you've learned and learn new things. So a lot of all the things you guys are showing us when we started this program a few years ago, they weren't in existence. Nobody will be talking about Gen AI or synthetically generating image and stuff like that, but it's becoming mainstream. So what that tells you is like a lot of all the things that you guys did that looks great right now, 6 months down the road it may be obsolete because there are better tools, better techniques to like solve the problems. People are always pushing the edge. There's a need to like commoditize the GPU so that it's affordable to most people to do a lot of all these cool new things. So I'll say like don't let the fire that is burning in you go down. This is just the tip of the iceberg, and you guys are still going to do a lot more greater things than this. So just stay focused and stay hungry. Just don't remain curious and try to learn new things all the time. So really impressed, and I'm basically going to go back and go through all the slides and see what I can take away from this. It's really impressive, and I'm proud of you guys. Great job, everyone.
All right, thank you so much. Isn't it good that Charles is proud of you guys? He's really proud of you guys, and he wants to go back to see your slides and see what he can learn from it. So that should be an encouragement to you guys. All right, Biodu, it's your turn now.
All right, thank you. Well, plus one to everything everyone has said. I think you all have taken this to the next level. I remember, it's probably like my third or fourth time being part of this panel, and the reason I've not been giving technical talk is because I feel like there's so much in the age of AI. AI is anticipated to it's anticipated to be a $2.5 trillion market, and that's huge. I'm gonna say general observation. Well, we've been talking. There's the talk about multimodality when it comes to generative AI. Throughout the course of the presentation, I've seen text generation, I've seen image generation, I've not seen video generation. I know this team can do it, and I see so many examples of how you could create video generation, and I can understand why you say, okay, yeah, we have resource constraints, and that's why we're not doing this or we're not doing that. Well, I see so many ideas that you all have floated here today that could be probably better presented with video generation. Like the wildlife use case or the decision making use case. There's so many of them. The other thing that I'll mention is plus one to what Peter has mentioned about like leveraging the power of the cloud. There's just so much that you all could do when it comes to leveraging capabilities that's in the cloud. Some of them might be free, and I've observed keenly a lot of the data generation that you have done having to go use other, find third party data. A lot of models that are out there could do a lot of synthetic data generation. It doesn't all have to be real, but the whole idea is the concept that you all are building. Finally, I really encourage you all to write about what you're doing because you might be the next AI company that's out there. they all talk about this AI hype cycle, and we are still at that hype cycle. But I feel like the more you all continue to see the application and people that you all can partner with in this journey of generative AI, with all these wonderful use cases that you all have come together to create, I just see so much that could be done and so much application that can come from the source that you all are on currently. And to Charles's point, I'm immensely proud of what this group has been able to achieve for the very short time that you all been working together, and what you could potentially achieve if you continue to take this journey even further. My contact is available if there's any way I could be of help, or anyone in my network can be of help. Again, immensely proud of the work that you all have done.
All right, thank you so much, Biodra. Thank you so much for all you've said, and it is obvious that has been an awesome experience for our interns. A big thank you to all the group presenters, teams, and judges, Charles, Biodun, and Peter, for a successful session. And we know our interns are going away with extra confidence because all three of our judges are quite proud of what we have all been able to accomplish. All right. So thank you so much. A big thank you to our judges. We are really honored to have hosted you on this episode of the MOE Capstone presentations. All right, all interns should please take note of the following. The results of the capstone presentation will be computed and published on Slack next week. And further announcements will be made on Slack concerning your certifications and other things going forward. On this note, we have come to the end of the presentations. A big thank you once again to our judges. We really appreciate you coming around to do this. Thank you to the presenters, and thank you to all of the other interns, as well as the ever-present AMUE team that made this all a possibility. Enjoy the rest of your weekend, everyone. Bye.
Thank you.
Thank you all.
Thank you too.